Hey everyone, Matthew Doyle here for Epic Games. I'm a technical artist and have worked in the media and entertainment industry since the year 2000. I've been creating both 2D and 3D content for most of my life, using tools like 3ds Max, Maya, Mudbox, ZBrush, and more. I also have extensive experience using Unreal Engine to create both games and interactive walkthroughs. If you've worked with the Unreal Development Kit, you may have seen some of my tutorials on the Scaleform UI tool on the Unreal forums and YouTube. I'd like to welcome you to this course on data preparation for Unreal Studio 4. In this course, we'll cover a lot of ground, everything from naming conventions and clean asset creation to proper UV mapping, LOD creation, collision, materials and textures, and finally export from 3ds Max into the Unreal Studio 4 editor, using Datasmith as well as other export options. If you've never worked with a real-time solution like Unreal before, but are familiar with creating 3D content in a tool such as 3ds Max or Maya, you can relax. Working with Unreal Studio 4 is a skill you'll pick up in no time. Most of the workflow will feel like working in a 3D asset creation tool, and a lot of the topics we'll cover can often be handled automatically by Unreal. What makes Unreal different than Max or Maya or Blender is the ability to turn your 3D scenes into real-time walkthroughs, allowing clients to experience your work as if they were actually in the environment. And with virtual reality, that experience can be even more compelling than before. For Epic Games and myself, I hope you find this course informative and easy to follow. By the time you've finished, you should have a strong grasp of how and why good data preparation is critical to creating highly performant and visually impressive real-time scenes with Unreal Studio 4. Let's get started. Before we get into the course, it's important that you are familiar with basic 3D content creation principles and workflows. You should understand the processes and be able to create content in a 3D package of your choice. In this case, we'll be using 3ds Max. But if you have a strong understanding of the topics covered, following along in Maya or Blender or whichever app you prefer shouldn't be a problem. While some of the exact steps and obviously the user interfaces are going to be different, the concepts are the same. Topics we're going to be covering, of which you should have a good grasp, include setting up your 3D scenes, units and alignment, working with geometry creation and optimization tools, modifying pivot points, creating UV coordinates, level of detail meshes, as well as working with textures and materials. We'll also be covering some topics that aren't typical parts of a non-real-time 3D workflow, such as the creation of collision detection meshes and light mapping UVs, although light mapping UVs is kind of related to baking lighting, as well as export and import into a game engine, in this case, obviously Unreal Engine. For a good explanation of some of these topics, it's advisable that you check out the Unreal documentation and the wiki for tutorials and walkthroughs. Now, the Epic Wiki can be found at wiki.unrealengine.com, or we can go into the launcher here and just click on Learn. And we can see at the top here, we have access to documentation, video tutorials, the community wiki, and then tons of stuff down below here. Let's go ahead and click on the wiki here. And here we go. Here we're at the Unreal Engine community wiki. Of course, we could do a search here and find all kinds of great resources on these topics. Now, many of the search results you put in here are going to point to the Unreal documentation, which, of course, if you just wanted to go there in a web browser, you could do that at docs.unrealengine.com. Using the Unreal Engine 4 documentation, you're going to have no trouble learning about topics you're unfamiliar with for this course. For instance, if you were to use the Unreal docs, we could find detailed information on, say, collision detection. So we see here we have a lot of results. If we just click on documentation here, this is going to give us all of the results in the Unreal docs. So in our list here of documentation, I'm just going to scroll down until I see physics simulation here and click on that. And that brings us to the parent topic of collision. So if we just open up collision here, we've got all kinds of great information on collision detection. So collision overview, collision how-tos, and whatnot. So definitely make sure you make use of the documentation and the wiki and all the video tutorials to get that leg up that you might need for this course. Of course, you're going to want to have installed Unreal Engine 4.19 or greater, as well as the Datasmith plugin. We'll talk more about how to set up Datasmith coming up shortly. as well as, of course, you're going to need a 3D content creation tool. And if you want to follow along, 3ds Max is going to be the best choice because that's what I'm going to be using exclusively in this course. Now, obviously, we won't be covering the basics of how to do things in the Unreal 4 editor or in 3ds Max for that matter, but I think you're quickly going to find out that many things we'll be doing don't require an extensive understanding of the tools. However, if you are completely new to Unreal Engine 4, it is definitely advised that you stop the course now and go through those basic tutorials provided for the editor. Now that we've got all that out of the way, let's go ahead and take a look at the exercise files and the Datasmith plugin in the next couple of videos. We'll see you there. As we proceed through the course, we'll be using a simple but beautiful V-Ray-based architectural interior provided to us thanks to TurboSquid. This course is not really a hands-on course, but if you have some assets of your own, feel free to pull them up and use them as you watch each step. The assets I will be working with here were built using 3ds Max, but you could just as easily be working with a Maya scene, Blender, SketchUp, or even Revit. Just keep in mind that the interface and workflow will obviously be different in each tool, but the concepts presented are the same. There are a few things to note about this scene before we get started. First off, the scene was put together using feet and inches. So if we go to System Unit Setup here, we can see that we're in inches here. And we're going to be looking at how to convert that scale to Unreal's centimeter-based environment. Also, none of the assets in the scene have good naming conventions. That includes meshes, materials, and textures. See here, all these are boxes and rectangles. But don't worry, we're going to be covering how to fix that too. Finally, as is sometimes the case with architectural scenes, many of the assets are composed of basic shapes. Take this coffee table here, for instance. We can see that it's basically composed of 5 boxes. So we've got a top, and then we also have 4 legs here. When working in Unreal, it's best to have our assets as complete actors or entities. And so, you'd want to have a coffee table, a couch, a lamp, etc., rather than having all of these individual shapes. Unreal will import the scene as is without any changes, and it'll look great. But a little cleanup and organization is going to ensure that it's much easier to work with your assets when it's imported. We'll cover naming conventions and unit setup shortly, but if you have a scene like this, it'd be wise to go ahead and combine the individual pieces into a single mesh object. And at this point, we can also collapse down any modifiers on the stack in 3ds Max.
Just make sure you keep a source file, an original file that has all your modifiers still, in case you need to use them.
So I'm going to go ahead and collapse this down here. And then we'll go ahead and also attach the legs, making this a solid single piece. And there we go. So now we have our coffee table. So now that you're familiar with the assets we'll be working with, let's go ahead and take a look at where to locate the Datasmith export plugin. This course can be done without using Datasmith and instead using standard FBX export, and we will be covering both options. But Datasmith allows you to export your assets from your 3D tool into Unreal with a minimum of effort and conversion woes. So Datasmith does most of the heavy lifting for you, so your work will look as close to identical in Unreal as possible. It also supports a slew of CAD data formats. But before you can use Datasmith, you of course need to install the plugin. So let's go over that process briefly. So here I am inside of the Unreal Launcher, and I'm going to go to the library page here. Now currently I'm using version 4.19, and this version has Datasmith bundled with it. So if we click on Installed Plugins, we can see here that I've got the Datasmith plugin here already. All right, now in the project browser, we can go to New Project. You're going to see a tab here that says Unreal Studio, and we can go ahead and create a blank project. Now, the Unreal Studio project is going to give us access to Datasmith, but you can actually add Datasmith to a project that was built using one of the regular Unreal project templates instead, and I'll show you how you would go about doing that. But let's go ahead and create a new blank project using Unreal Studio. And we'll just call this Data Prep 04. Okay, so here we are inside of our new Datasmith 04 project. And finding Datasmith is really easy because this is an Unreal Studio project. We just look to the top here and there's Import Datasmith file, Import uDatasmith file here. If we do the drop down, we can also see we can import CAD data. And that's as simple as it is. That's the button we'll be using. We'll actually go over this in more detail when we get to that segment. But for now, this is just where it is. You can also go into the File menu and do an import into level, and that will also import uDatasmith files. So we can see here we've got uDatasmith as one of the file options. Let's look real quick at how you would convert a regular Unreal project into an Unreal Studio project and get the Datasmith plugin. All right, so I have here the example project that you can download for free from the Unreal library. We're just going to go into Settings and then Plugins. If we scroll down, you will find Unreal Studio. Now you'll see here we have the Datasmith CAD importer and the regular importer, but they're grayed out and we can't use them. And that's because this project is not an Unreal Studio project. We can see here the warning. We're just going to go ahead and convert the project and restart the engine. And that's going to give us access to these plugins. So we've restarted Unreal. We'll go back down to Unreal Studio. Now we have access to the plugins. Of course, they're already enabled for us. We'll just go up here and there they are in the top bar. We can import Datasmith files. However, there is one other side to Datasmith, and that is the 3D Studio Max side, or whatever tool you're using, the plugin for that. Let's jump over to 3ds Max and find out where we can access Datasmith. Now, of course, you're going to need to have downloaded and installed the 3ds Max plugin ahead of time. All right, so here we are back in good old 3ds Max. We'll go to File and then Export. We can do full export or export selected. We've got the coffee table selected here. Let's go ahead and just do export selected. And if we scroll down in our Save As type, you'll find Unreal Datasmith there. That's a uDatasmith file. We'll give it a name, coffee table, just a quick name there. Hit Save, and that's going to bring up the Datasmith export options. As you can see, there's not a lot here. We're going to talk more about exporting and importing with Datasmith later, but there you go. That's how you find Datasmith and use it to export. So you're ready to begin your foray into data preparation for Unreal Engine 4. And we'll see you in the next segment where we'll be going over initial setup and organization of your asset.
The first step of any endeavor is having a good plan. This is just as true when it comes to preparing your data for a live walkthrough using Unreal Engine 4. Deciding on proper naming conventions for your assets is an important part of our plan. Proper naming conventions will make sure that you and anyone else involved with the project knows what each asset is at a glance and how to locate specific assets. Searching for assets becomes that much easier thanks to consistent naming conventions. Naming conventions are critical to keeping your data organized and avoiding any potential errors when working with it in a 3D tool or the Unreal Editor. The last thing you want to be doing in the middle of a project when you have hundreds or even thousands of assets is digging through endless materials named number material 1, 2, 3, 4. Every project is different. However, we can go over some common naming conventions for some of the most widely used assets when working with 3D content. First up, let's establish a few ground rules. Never use spaces when naming things. If you need a space, use an underscore instead. Or use something like camel case, which you see here, to differentiate words without using spaces or underscores. Avoid using any other special characters like number signs, dollar signs, etc. These characters can potentially cause issues and generally don't add any easily recognized information to file names. Bear in mind that Unreal Engine does not enforce naming conventions, so it's up to you to make sure you do. A best practice for naming assets is to use a simple pattern of prefix, asset name, suffix. You can separate those names using underscores if you like. The prefix, suffix, and name of an asset should be as short as possible to convey the information. Let's look at each part of the name now. A prefix is a short description or code. It can be as short as one letter, and it basically tells you what type of asset it is. For instance, here's a short list of prefixes you can use. Notice here that we have T for texture, M for material, SM for static mesh, etc. While you're no doubt familiar with assets such as textures and materials, some of these may be unfamiliar to you if you are new to Unreal. So be sure to check out the basic Unreal tutorials to learn about static meshes, skeletal meshes, material instances, etc. for more info. Next up, we have the name of the asset. This is pretty self-explanatory. For instance, if the asset is a material, it might be named wall stucco or wall_stucco. Again, keep this name short and sweet, but descriptive enough to give you the info you need. Some authors will number their assets that have similar names. For instance, you might have 2 or 3 materials that are all basically wall stucco materials. You could name them wall stucco 001, wall stucco 002, etc., but it could be just as good to be more descriptive with the names. So for example, you might use wall stucco tan and wall stucco brown. Just remember to keep it short. Suffixes aren't always required, but when they are, they follow similar rules as prefixes. Textures are a great example of when a suffix would best be used, as there are many types of textures. Let's look at some example suffixes for textures. So we can see here we have D for diffuse, N for normal, S for specular, and so on. Again, keep the suffix short, and that will help avoid overly long asset names. Most authors will recognize the suffix codes for each asset. Alright, so naming conventions aren't required to create scenes in Unreal, but using them will save you lots of headache and frustration down the road. The naming schemes we provided here are a great start and generally accepted as standard in Unreal. However, any naming scheme you choose will work just as well, as long as you understand what it means, and it easily conveys that same information to anyone else that might be looking at your assets. Up next, we'll take a look at setting up 3ds Max to match Unreal's units and alignment, and options for dealing with scaling issues in your source 3D scene. When transferring your assets between 2 different applications, such as the case here where we're going to be using 3ds Max and transferring this architectural scene into Unreal, you have to first make sure that you have set up your unit measurement system or the scaling of your object, as well as the coordinate system for the orientation of those objects to match Unreal's system as closely as possible. So Unreal uses the metric system where 1 centimeter is equal to 1 Unreal unit, whereas 3ds Max uses kind of a generic unit system. Now bear in mind, however, that in 3ds Max you do have a lot of options for adjusting the scale, but some of those options do not actually affect the scale, they simply affect the view of the measurement system. So if we go into Customize and then Unit Setup here, we can see here this display unit scale, which is currently set to US standard feet. We're going to change that to metric centimeters. But honestly, this doesn't have any bearing on exporting the assets into Unreal. This is purely for demonstration in Max so that you can basically work in the metric system as far as the measurements that will be displayed in the modifier panel and whatnot. So if we go into the system unit setup here in 3ds Max, this will allow us to choose what units to use for our scene scale. So if you're working on a new project that you plan to send to Unreal, it would be best to set your system units in centimeters from the get-go. So we'll just change it here from inches to centimeters. As an author, you may, however, be provided with scan data or assets created in another package. In this case, you should proceed with caution when changing the scale of the scene, as this could introduce some scaling-related issues. One option you have is to set Max to use centimeters, then load the scene that uses another unit scale, and choose to rescale the file objects to the system unit scale. Verify everything looks good using a simple stand-in object to represent a human at roughly 175 centimeters tall. You could also try using the Rescale World Units utility in 3ds Max. Use a scaling factor of 2.5 to go from feet and inches to centimeters. And finally, another option is to simply manually scale every asset in the scene. Now this is obviously not the easiest way to do this. If your scene is in feet and inches, then you'll need to scale all your assets by a factor of 2.5 or 250%. Of course, you should do this after you have set your scene's working units to centimeters. Now, regardless of which method you choose, you're going to want to
reset the transform on all the scaled objects, and this will bake those changes in. Now, a few things to keep in mind when working with very large scenes. In this case, we have kind of a medium-sized interior architectural scene, but sometimes you might be working with an entire building, maybe a high-rise, an apartment structure, or even an entire city block or more. When you're working with those really large scenes, bear in mind that the further an object in your scene is from the origin of the world, that is 0, 0, 0, there are more chances for rounding errors in the math that is needed to display those objects accurately and without any kind of graphical glitches in Unreal. This can also happen with scenes that are extremely small. So for instance, if you have really small details, such as these books here and magazines and any other doodads that we have back on the shelves back here, if there are any of these details or any details on these objects that are smaller than the standard unit inside of 3ds Max or whatever package you're using, that can lead to glitches as well. So to avoid this as much as possible, be sure that your scenes are roughly centered on the origin of the world at 0, 0, 0, and avoid creating those assets or details on those assets that are smaller, again, than one generic max unit, basically. Or in this case, we're using centimeters, anything smaller than a centimeter, for scaling your assets on export and import. Now, you have multiple options for export. You can export options one at a time. You can export the entire scene. You can use FBX export, you can use Unreal's Datasmith, and we are going to cover most of that later on in the course. But for now, just understand that you have those options. And we're going to look at FBX export first for a single asset and what you can do to scale the object. Now, bear in mind that it's best to avoid this type of what I call one-off scaling, and instead fix the assets in Max so that they're the right size. Have your entire scene created in the first place in the correct size. If you can do that, that's even better. But if you don't do any of those things and you do need to scale your assets, let's look quickly at some of the options you have. So here we have this mesh here that we're going to export, and we'll just go to File Export, and we'll choose our FBX file format. All right. And so if we look in the advanced options of FBX export, normally this is checked by default, this automatic option here, and the scale factor we can see here is set to 1. So it's not going to be scaled at all when it gets sent over to Unreal. If you need to change that here, you can just uncheck the automatic, and we can change our scene units. Since we're set up correctly here in centimeters, we could make this meters. We can see when we do that, the scale factor becomes a 1/100th of what it currently is. We could also go to kilometers or inches or whatever the case may be. But again, we're already set up correctly here. And again, I advise against doing this kind of scaling. You want it to be correct in the source asset, and that way when it does export into Unreal, it will be the same size. Everything will match exactly as you expect it to without doing this kind of one-off scaling. So now when we're in Unreal here, we can do the same thing with the import options. So go ahead and import that FBX file. And we can see here we have a couple of options. Under Transform, we have this Import Uniform Scale. We can basically scale up the asset here. Just type in the value we want to scale it by. Maybe we need to scale it by 10. We could do that. And we can also, under Miscellaneous, you can see here we have this basically Convert Scene Unit. We can convert the FBX units. Maybe we're working in Max generic units. We can convert those into the Unreal Engine 4 centimeter units. Now again, avoid doing this kind of one-off scaling. It's best to fix it in the source material, and then when you export it, it will come in the right size. In this case, our scene here, go ahead and cancel this because we've already got everything imported. The scene here is exactly set up the way it should be because it was set up as centimeters in Max. It came over as centimeters, and so everything is perfectly scaled already for us. With Datasmith, all of this is done for us. So if I go ahead and give you a quick sneak peek of the Datasmith exporter here, if we go to File Export again, and in this case, we're going to choose the Unreal Datasmith format here, Viz Interior. So here we can, obviously choose just the selection or visible objects, and that's it. Those are our options. So when we hit OK, it's just going to send it out whatever size it was, but Datasmith does a great job of interpreting all the data so that it comes out in Unreal the way Unreal likes it. Datasmith was designed to be very simple to use, one-click workflow basically to bring all of your assets in. You can bring entire scenes in at once. And the great thing is it does all this magic in the back end that basically translates everything into the proper format for Unreal. Now, as for alignment or the coordinate system, Unreal uses a left-handed Z-up coordinate system, while 3ds Max and some other packages use a right-handed system. Now, this isn't a huge problem. Generally, when you bring your assets into Unreal Engine, they're going to be facing in the correct direction, and the top will be up and the bottom will be down and so forth. But there is a possibility, based on your import options, that your asset might come in rotated by 90 degrees, I believe, counterclockwise. And there is a way to solve that to make sure that your assets are matching identically inside of 3ds Max as well as inside of the Unreal Engine when you import. So let's take a quick look at how you can ensure that. So what we're going to do here is I have my fireplace selected inside of 3ds Max. I'm going to export 2 versions of that so that we can have 2 test cases to look at. And we'll just go ahead and export it once. So export selected. And I'm not going to change any of the default options here. We're going to leave scale factor to automatic. Axis conversion, the default there is Y up. We'll go ahead and leave that. And I'm going to export it one more time. And we'll just name it number 2. Same settings, no change here. I could probably use the same FBX file to re-import it twice to show you the same thing, but I wanted to go ahead and have 2 different versions that we could bring in at the same time. If we go into our 4-up view, we can see our fireplace here in the front viewport. That's our front viewport, top right. And again, if we look in the top viewport here on the left, we can see the fireplace here facing down into the room. So we know for sure that this should be facing forward. All right, so let's go ahead and import it into our scene here. This is the fully imported scene already. Everything is the correct size and facing in the correct direction. But just for a quick test case, we'll go ahead and re-import the fireplace. We'll start with the first version here. Now, under miscellaneous here, we have our 3 options that we're going to be looking at. We have convert scene, and this basically converts the scene into the UE4 coordinate system. Again, that's the left-handed Z-up coordinate system from whatever's in the FBX file, which is, in this case, a right-handed coordinate system using 3ds Max. And we'll go ahead and check that. And we're going to also check force front x-axis. And we'll keep that, convert scene units to centimeters, and we'll go ahead and hit import. And let's just drop them into the scene, and you can see right away something's not right. It's the right size, but it's facing 90 degrees. That would be counterclockwise, actually, and that's not what we want. So we'll go ahead and delete that, and we're going to re-import. And actually, we're just going to import the second version that I exported. And this time, the only difference is we're going to uncheck this force front x-axis and import that guy, drop him into the scene. And now we can see that this guy here is facing the correct direction and is the correct size. All right? So that's really all you need to do to make sure that when you're importing your assets using the FBX import option, to make sure they're facing in the same direction as they are in 3ds Max, make sure you check that option, that force front x-axis. Again, with Datasmith, you're not going to need to do that. It's going to do it all for you automatically. And, of course, you're going to get to bring in every asset in the scene. And we'll talk about that when we get to that part of the course. Working in the correct unit scale and in the correct coordinate system or alignment is the first step to ensuring the data in your Unreal scene matches the source data in your 3D tool, whether that be 3ds Max or Maya or Blender or whatever other tool you might be using. It will also help you avoid graphical glitches in the final walkthrough when you follow some basic rules about asset positioning and the size of your world in relation to the world origin, remembering the further away your assets are from the world origin, the more chance there is for graphical glitches due to the lack of precision when things get really far away from the center of the world. So it does take a little work to set up, but it's very important to do so when preparing your data. And a little effort here can go a long way toward creating an organized and high-fidelity experience in the end. Up next, we'll dive into a few of the most common ways to export your assets to Unreal. Before we dive into the preparation needed on your assets, let's look at the export and import process to get those assets into Unreal, because we're going to be using it a lot throughout the course. This is where the rubber meets the road, and it's a simple 2-step process. If you've done a good job preparing your assets, this part should go smoothly. But even if you haven't, Unreal does a great job of bringing assets in that aren't optimal. The 2 ways we're going to cover to export your data from your 3D tool are FBX export and Datasmith. With FBX Export, assets are exported one at a time. Let's export this coffee table from our previous chapters and take a look at the FBX Export options. Of course, the coffee table is a solid single piece composed of the different shapes. We've gone ahead and attached those together. And we've named it using good naming conventions here. So we've got SM_coffee table. And notice obviously that the stack has been collapsed, so we don't have any modifiers on it. So we'll go ahead and just go to File, Export Selected. You probably already know where this is at. And we will name this the same name we have inside of 3ds Max here. So SM_coffee table. Now, inside the FBX export options, we're going to make sure this is set on the default for now. Autodesk Media and Entertainment, the preset. And under Include, if we open up Geometry, we'll go ahead and check Smoothing Groups, though I know that in this case we don't have any smoothing groups on the table. But if you have something more organic like a pillow or a couch or any of those types of things that do use smoothing groups, go ahead and turn that on because the export process will take those smoothing groups along with it and Unreal will recognize them. We're going to skip over the rest of this stuff and drop down to Triangulate. You don't have to do this one here because Unreal basically automatically turns every mesh into triangles. And even though technically all 3D meshes are in fact based on triangles, sometimes when you build them, obviously you might build them with quads, four-sided faces instead of triangles. And this will just automatically turn those quads into triangles for us when we export. If we have any animations in the scene, obviously you want to have that checked. Generally, in architectural scenes, there's not a lot, if any, animation, but we'll go ahead and leave it checked. We can also bring in cameras. Just make sure that's checked if it is. You can certainly export animated cameras and bring those into Unreal and use them in Unreal's sequencer. If, of course, you're using any lights that you want to bring over into Unreal, Unreal will be able to import most lights. And then embed media, we don't need to check this because Unreal will automatically locate the textures for the materials on your hard drive, so you don't need to send over the media with it. Now, under Advanced Options, we already talked about this in our chapter on units. We want to be sure we're using centimeters, and we'll just leave this set to automatic scaling. Under Axis Conversion, we want to use Z up here. If we don't export with Z up, we might have some incorrect orientation on our assets when we export and bring into Unreal. And that's really all we need here. So again, just to recap, we want to use smoothing groups. We want to triangulate. If we're using cameras and lights, we want to turn those on. And then finally, automatic scaling set to centimeters and Z up for our axis. All right, and now we're not going to actually jump over into Unreal to show the import process. We're going to do that in the next video. Let's just go ahead and look at Datasmith now. So Datasmith gives us a lot of great advantages when exporting into Unreal. First of all, you can export a single asset, such as this coffee table, but the real power in Datasmith lies in being able to export the entire scene in basically just a few clicks. On top of that, Datasmith does a lot of great stuff automatically for us. So you saw in the FBX export options, we had to check a lot of things off and make some decisions. But with Datasmith, it does all that for us pretty much automatically, and it respects instances as well. So that means that it will only create one asset in Unreal, but make sure that if it's an instanced asset in our 3ds Max scene, such as the case with these lamps here, I have a source lamp, and then I have 3 other instances of that lamp. It's going to make sure that those instances are placed in the same spot in the scene in the correct location that they are obviously here in 3ds Max. It also converts textures and materials, adjusts the working unit scale and coordinate system, pivot points, scene hierarchy, and more, all automatically. And it automatically generates light map UVs if we need those. And obviously when we're going to render light maps, we do. And it can convert grayscale bump maps to normal maps for us automatically. So let's go ahead and see what that process looks like here. So it doesn't matter if we have anything selected because we're going to export the entire scene here. So let's go to File, Export, and then we'll just scroll down to UDatasmith, Unreal Datasmith here. And we'll name this ArchViz 001. So you can see here we're going to include all visible objects and just hit OK. So now we can see that Datasmith export is going on down at the bottom here, sending out all of the meshes as part of that Datasmith file. So once the Datasmith export is processed, you're going to get this output warnings window, and it's going to tell you any kind of issues it might have run into while exporting, such as incorrect textures or missing textures. It'll even tell you any kind of issues with partially supported material formats, such as this two-sided V-Ray material here that is not currently supported, missing textures, as I said, and so forth. Now, let's actually take a look at the export location here. There's a few things to take note of. First of all, the UDatasmith file here is actually an XML file. So if we open it up, we can see all of the export properties for all of the various assets in our scene are stored here. Now, generally, you don't want to modify this. This points to all of those assets and gives you the information that Unreal expects when it imports the Datasmith file. But inside here, we also have a folder that contains all of those assets. So if we go in there, we can see we've got all these UDS mesh, Datasmith mesh assets here. These are all the different parts and pieces of your scene, as well as the textures and materials for those. All right? Unreal supports several data formats, including FBX and Datasmith, and it can bring in all sorts of CAD data formats. Exporting that data is the first step to getting into the Unreal Engine, and it's likely something you're already comfortable doing if you've worked in 3D content creation for even the shortest length of time. Now that we've covered the export side, we're going to look at how we import our assets into the Unreal Engine. Now that you've exported all your assets from the tool, importing them into Unreal is easy. Remember, Unreal is quite forgiving of poorly prepped data when importing. It'll import unoptimized 3D meshes no matter if they're set up using the same coordinate system and unit size or properly named assets for that matter. But if you follow this course and perform all the prep to your data as advised, the data will come in beautifully ready for creating your live walkthroughs. Last time, we showed you the different ways to export your data using Datasmith and FBX Export. This time, we'll look at those formats as we import the data into the Unreal Engine. Let's start with FBX Import first. Let's go ahead and click on Import here in our Unreal Studio project. Here's our coffee table mesh asset. Now in the FBX Import Options window, the first thing we want to do is uncheck Skeletal Mesh under the mesh settings. This is a static mesh. A skeletal mesh would be a character that's rigged for animation. And obviously when we're doing architectural visualization, most of the time, maybe 90+% of the time, we're not going to be using those types of meshes. So we'll uncheck that. Next up we have Auto Generate Collision. Now we're not going to go into detail on a lot of these options right now. I'm just going to show you where they are in the import options here because we will be covering them in a later chapter of the course. We'll go ahead and leave this checked for now. Under this, we have a little Show Advanced arrow. Let's open that up. Don't be intimidated by all these options. For the most part, you're not going to need them for bringing in your architectural visualization assets. We do want to look at Generate Lightmap UVs. We will talk about Lightmap UVs shortly, but for now, just know, keep this checked, and Unreal will generate those UVs for you for baking light maps. Next up, we have our Transform Vertex to Absolute. This is checked by default. We're going to uncheck it because I want to use the pivot point of the coffee table. If you check this option, what it's going to do is it's going to set the pivot point for all of your mesh objects that are imported to match with the origin of the world. Now, this is a great option to check if you want all of your objects to be in the exact same spot in 3ds Max and in the same spot in Unreal. And what you do is you basically drop the asset into the level and set its location to 0, 0, 0. And then everything that has this option checked when brought in will basically be set up so that it's in the exact same spot from 3ds Max, using the world origin as its pivot. Below this, we have our Import Mesh LODs. This is unchecked. We're going to leave it that way since there are no LODs on this coffee table right now. Now below that, we have our Transform options. We're going to leave Translation and Rotation at the default settings of 0, 0, 0. We don't want any offsets here. And the Import Uniform Scale option, which we talked about in the Units Setup chapter of the course. We're going to leave that at 1.0. Then under Miscellaneous, we have, again, some options we've already talked about in the Units Setup chapter. We've got Convert Scene, converting our FBX coordinates to the Unreal 4 coordinate system, left-handed versus right-handed. Then we have our Force Front X-axis, which has to do with changing where the X-axis is on the mesh object. And finally, Convert Scene Units. We can check that if we want to maybe convert inches and feet to centimeters. But again, we know this asset is already properly set up using centimeters. Now below this, and if this isn't open for you, this little arrow here, make sure you open it. You're going to see Override Full Name. Keeping this checked will ensure that when you bring in the asset from an FBX exported file, it's going to use the file name as the asset name in Unreal. So the file name is sm_coffee table. That's what it'll be named inside of Unreal. If you uncheck that, it'll use a different naming scheme. So the asset will come in as sm_coffee table. And I think after the file name, it uses the asset name from 3ds Max. So it would basically be the same thing duplicated, which would be redundant. So we'll just leave this checked to make sure we're just using the file name. So below this we have the material settings, and this is the problem we have using FBX export when we're using V-Ray materials, which is the case with this particular scene. It doesn't support V-Ray material formats, so you're going to end up getting the material converted into just a standard material format here in Unreal, and you'll have to set up the material yourself. Now you're going to find that Datasmith does support V-Ray materials on export, so you won't have to do any of that there. But in this case, we're going to have to import, it does import the material name and everything, but we're going to have to manually set it up and import the textures ourselves. So let's go ahead and just import our asset. And so we can see here we've got our asset, and we do have the material, but none of the textures, and it's not set up. We'll go ahead and drag the asset into the scene here. And if you want to do a quick test to make sure that it is the right scale, you can go into your geometry tab here and choose a cylinder or something, drop it into the scene. And then we'll set the Z to 175 centimeters, the radius to 30, and that's about the size of a 5'7" person, and you can see there it's about right. So that should be set up properly as it is in 3ds Max. So to bring in the actual textures, we'll just use the import button again. I've got the textures exported to a separate folder here. I'm just going to select all 3 of them and bring them into Unreal. And of course at this point you would need to open the material and use the Unreal Material Editor. And if you're familiar with using the Slate Editor in 3ds Max or any other visual shader material creation tool, it's going to work a lot like that. So we've got our base diffuse color here. We could apply this as a texture map, and we can do specular, roughness, and so forth and so on. But this isn't a course on setting up materials. If you want to find out more about how to set up materials and apply textures and whatnot, be sure to check out the Unreal tutorials and wiki on those subjects. So working with FBX, you'll be able to import all of your assets, all of your 3D geometry, as well as the materials and lights and cameras even. Again, if you're using something like a V-Ray material, you're going to have to import the textures yourself and reset those materials up. Of course, Datasmith can import all of those things as well, including V-Ray materials, and it can even import entire scenes in just a few clicks. We'll discuss Datasmith import next. Now let's take a look at Datasmith. I think you'll find that Datasmith does a remarkable job of bringing in your assets with the least amount of effort. Let's go ahead and import our architectural visualization scene here that we exported. Now, the really cool thing about Datasmith is that it does a lot of work for us. So there's really very few options in the Datasmith import window when compared to FBX. That's because Datasmith's really smart, and it does most of the config stuff for you without you having to tell it to do so. The other beauty of using Datasmith is, of course, that you can bring in entire scenes into the engine in just a few clicks. And it will save each asset of the scene as an individual Unreal asset. So geometry will be converted to static meshes, etc. So let's look at some of the options here in the import window. First up, we have the ability to specify where we want the scene to be saved, the Datasmith file. I've already created a folder here called Datasmith Assets. If you want to create your own, obviously you could just right-click and choose New Folder. So we'll go ahead and hit OK. And in the second window here, again, we don't really have a lot of options. We just need to specify if we want to import geometry and materials and textures, and of course we do. We could also import lights and cameras, just as we could with FBX import. But of course we don't have any lights or cameras in this particular scene, so we won't worry about that now. Finally, we have static mesh import options for the light map resolution, and we'll get into this a little more when we talk about generating light map UVs. But basically we can specify the minimum resolution and the maximum resolution, and that's in texel size. So 64 minimum, 512 maximum. Texels being, if you're not familiar with them, basically like pixels, but in a 2D texture map format. And so obviously the more texels you have, the greater your light map resolution will be. Let's just go ahead and hit the import button and bring it in. All right, so let's go ahead and drop a point light in here because we currently have no lighting. There we go. This is just a temporary solution so we can see the assets in the scene. Now, if you want to learn about light map baking, this course does not cover that. We will go over basic data prep for getting your assets ready for light mapping, but we won't be covering actual light baking. So if you want to learn more about that, you don't already know that, be sure to check out the Unreal Wiki and docs for some great tutorials on how to create light maps, as well as learning courses on that. Now, Datasmith is smart enough to generate instances just the way you have them set up in 3ds Max or whatever tool you're using. These 4 lamps are, in fact, instances, as are these 2 couches. These are instanced, and some other objects in this scene. And what Datasmith does is it only generates one asset in your content folder, and all of the rest of the assets are instances. So if we click on the lamp and then right-click and choose Browse to Asset, you can see there's only one lamp here and it's being duplicated. And this is going to save memory, so you're not loading 4 of the exact same lamp into memory, and that's going to improve your performance. It also means you can tweak one of them and then see them all change. So in order to do that, let's go ahead and jump back into 3ds Max. All right, and what we're going to do is we're going to make a quick tweak to this lamp here. We're just going to elongate the shade, just like that. Okay, you can see here, since these are all instances, they are also changing. And then we'll need to re-export the scene. And we'll do that. I'm going to go ahead and pause the video here, and we'll come back when it's done. All right, we've re-exported the Datasmith file. So all we need to do now to see the changes in Unreal is we'll select our lamp here in the content folder, right-click it, and choose Re-import. And there we go. So iteration time is greatly reduced using Datasmith. Re-importing assets that have been changed in the 3D package is as easy as using the re-import option. Granted, if you're doing an entire scene like we are here, you're going to have to re-export the entire scene from 3ds Max and then import it back into Unreal. But when you import it back into Unreal, you don't have to import the entire scene. You just import individual assets wherever you made those changes. Unreal does offer some other import options which we didn't talk about today. Be sure to check out the documentation on the wiki and whatnot to find out more about that. So next up, we'll jump right into the main part of the course on data preparation and look at how properly located pivot points can help make 3D assets in Unreal behave the way you expect them to.
Being able to translate and rotate a 3D object in a predictable manner depends largely on whether you've spent the time to set up its pivot point. Pivot points will work the same way in Unreal as they do in your 3D tool. Technically, you don't have to set pivot points up at all, but for the best experience in Unreal, place your pivot points on each asset where you want it to snap to other objects and where you want to be able to rotate it from. Also, be sure all pivot points are Z up. Otherwise, your asset might be incorrectly oriented on import. If you do have to change your pivot point, be sure to reset the transform in 3ds Max. Otherwise, the asset's pivot point when exported to Unreal will match the old pivot point orientation. Take this lamp for example. The pivot point is on the bottom of the object, where the base of the lamp meets the table, and it's centered on the lamp in such a way that we can easily rotate it around the center. This is the same behavior you're going to see in Unreal. If you're exporting an entire architectural interior or building, one option is to have the pivot point of each asset in the scene at the origin of the world, rather than inside of the geometry itself, while the geometry is located elsewhere. This has the advantage of making sure the entire scene is easily adjusted, as all the assets share the same common pivot point at 0, 0, 0. When exporting with EpiX, the assets won't be in your Unreal level already, and you'll have to drag them into the scene one at a time. But if you've used this technique, the assets will be positioned in the same location they were in the 3D tool, without needing to manually be moved or rotated. Of course, you'll have to make sure that they're all positioned at 0, 0, 0. It really depends on how you want to work. And remember, sending the entire scene at once using Datasmith means everything will already be set up in the correct locations. So adjusting pivot points isn't actually necessary for Unreal to be able to import your assets. Unreal is very forgiving in that way.
But making sure you've set your pivot points up in this manner will make moving and rotating those assets in Unreal afterwards a lot more consistent. Up next, we'll look at the various types of UV mapping Unreal supports and how and why you want to use them when preparing your data for export. UV mapping is every 3D artist's least fun thing to do, but it does have to be done, at least for now. Who knows what tech will be introduced in the future that solves the UV mapping conundrum. UVs work in Unreal no differently than they do in virtually every other 3D application, so there's not much new to learn here when setting them up. Just keep a few things in mind when generating UVs and you'll be fine. How you create UVs for a given asset depends largely upon the way you intend to texture that object. A common practice in architectural visualization is to apply a simple world projection map to texture all sides of an object. Textures can easily be tiled this way. This technique will work fine in Unreal as well. Just be sure, if you want to be able to scale the texture, to add a multiplication modifier to the material to do so. Let's go ahead and look at how to tile that texture inside of Unreal Studio. We have the same couch here. I'm just going to double click on the material here. All right, and we're just going to tile the base color of our material. So I'm going to pull off of the UVs here, the UV input on the texture sample. And then we're going to type in multiply. There we go. Just add that math node there. Now off of the A of our multiply, we're going to add the texture coordinates. We can spell coordinates right there. There we go. Texture coordinate. And then off of B, we'll multiply that by a constant value, which is right here. So now we'll specify, if we were to set this to 1, that would be the way it currently is tiled. If we set it to 2, that'll multiply it by 2. So just watch the viewport here. All right, and there we go. We've tiled it by 2. And obviously we could change this to any value we want. Let's go ahead and set it back to 1 for now. Be careful that your UV maps consider that the viewer can walk around in the scene and see things from angles you don't expect them to. This painting, for instance, was never meant to be seen from the side in still renders. It has obvious UV mapping issues that will need to be corrected before sending it to Unreal for a real-time walkthrough. Another option for UVs is to create clean, non-overlapping, unique UVs. Those UVs should basically take up space 0 to 1 and, as we said, shouldn't overlap. This is used a lot in video game development where textures are often more complex with lots of baked-in information and non-tileable details, such as pinstriping on a car panel or small graphics on a person's jacket. In this case, the best option is to manually create your UVs using the 3D Tools UV editor. Just be sure the UVs are, again, non-overlapping, have adequate space or padding between themselves and the edges of the texture border, and don't go past space 0,1 on UV coordinate space. Either method works great in Unreal, but if you find that materials look strange in Unreal, the first place to look for issues is more often than not either UV problems or overlapping faces. This leads us to our next topic, lightmap UVs. If you've never worked in real time, you may have never used lightmap UVs, but I think you're going to find that it's really not that difficult of a concept to understand. We'll discuss why they're needed and how to create them up next. If you've never done baked lighting, lightmap UVs may be new to you. Generally, when doing architectural visualization, you create material UVs and then essentially hit render. All the lighting information is rendered into the 2D image or video you create. You may even render out separate passes with directional lights, ambient lights, shadows in their own images and whatnot, and then combine those later by compositing. Now, baked lighting is done in a similar fashion for real-time walkthroughs, but in order for baked lighting to be created, you first need to generate lightmap UVs. Lightmap UVs work identically to material UVs. They're just used for lighting information instead of material information, allowing for a very high-quality global illumination scene to render in real time. GPUs are still not powerful enough to handle true GI quality at real time using dynamic lighting. That's why we use baked light maps. Unreal Studio supports both dynamic and static lighting. Now the difference is dynamic lighting is a light that can have objects move past it or through it, and they will project shadows and be affected by the light, and the light itself can move as well. Now this is great for real-time simulations that involve a lot of moving parts and characters moving through, and it does project shadows and everything, assuming of course that cast shadows is checked, like my sunlight here. But it can be very expensive because it's having to calculate these shadows and lighting at runtime every tick, which could be 60 frames a second.
It could be 90 frames a second in the case of VR, or whatever the case may be. Now, the other option would be static lighting. So I can set my light to either stationary or static. And when you put it to static, it means that the light will be fully baked. There will be no dynamicness to it. The shadows won't be dynamic. The light can't move. And anyone that would move through it, if you had a character move through it, they would not project dynamic shadows. Everything is baked into the light map. Now, the good thing about static lighting is it doesn't have to be calculated the same way as dynamic lighting at runtime, so you save a lot on performance. However, the negative side of it is that it does take up more memory because you're having to bake the light maps, which obviously take up space in the video card's memory. Now, the benefit that static or baked lighting has over dynamic lighting is that just like with your renderer in 3ds Max or Maya or Blender, say V-Ray, you're going to be able to get that high quality lighting. So you're going to get global illumination lighting with bounces and color bleed and all of that. Now, obviously right now it says preview on my meshes here in Unreal. That means I need to bake my lighting because currently my sunlight is, we set it to movable or dynamic, and that cleared out the lighting, the baked lighting, and then we set it to static. So now we need to rebake the lighting. Also up here, it would tell you normally that lighting needs to be baked, but I have my stats turned off. Turning that on, we can see we've got a red message here reminding us that we do need to bake our lighting.
The good news is creating lightmap UVs can be as easy as pressing a button. As we saw earlier, the Unreal Studio import options allow you to automatically generate lightmap UVs. Unreal does a fantastic job of creating non-overlapping lightmap UVs that generate great results. Now, if you need greater detail in the lightmap for a given object, you can easily adjust the lightmap size both on import as well as later on in the assets settings, or even on a per instance basis in the instance properties for a given mesh in the scene. Alternatively, you can create your own custom lightmap UVs in your 3D tool. This is sometimes necessary when working with very complex organic shapes, such as curtains, covers, or in the case of the couch here, these pillows. All right, so we have the lightmap UVs up for the couch here, and there's a few problems that we need to solve. First of all, lightmap UVs cannot overlap. Now, when you're doing projection mapping for diffuse textures, obviously you can overlap your UVs. That's not a problem usually. But when you're doing light mapping UVs, when the lighting is going to be baked in Unreal, none of these UVs can overlap. They have to all have unique coordinates. So what we need to do is just pack these UVs so that they no longer overlap. Now, any 3D tool is going to have packing tools. So if we go in 3ds Max here, we've got our Pack UVs tool. And one thing we want to also make sure is that we set our padding. At least a value of 0.01 is generally what I use. You could use as high as 0.04 possibly. The point is you want to make sure that these UVs are not too close together to the edge or themselves, because that will cause light map bleed. So you'll see perhaps black where it should be white and vice versa. So I'm going to leave this at 0.01. All right, and so there are our unpacked UVs, nice and clean, not overlapping anymore, and we've got good padding between them. And that's going to help avoid light map bleed. Now, another thing we want to do is fix any bad seams we have in our light map UVs. Just like with diffuse textures UVs, you don't want to have seams in obvious places. It will be especially noticeable with light maps. There will be noticeable seams in the lighting, harsh lines and whatnot, especially where the shadow meets the light. But obviously, we'd need to come in here with seaming tools and basically weld these seams together in such a way that the front face of the pillow here is a single shell, and then, maybe it's broken along the sides of the pillow, and then the back is a single shell as well. And that way you're going to avoid any light map seams. So over here in Unreal Studio, we've got the static mesh editor open. We'll go ahead and show the UV channels for channel 0. This is the projection mapping for the diffuse texture. And then we have channel 2 down here. This is our light map UV channel. Bear in mind the channels in Unreal are 0 based, so this channel 0 corresponds to channel 1 in 3ds Max. Channel 2 is our light map channel, and then over here on the right under details, under general settings, you'll find light map coordinate index, and this is where you can specify which UV coordinates you want to use, which channel. And so obviously we have it set for channel 2 to match up with our light map UVs. Now, once your lightmap UVs are set up, baking your scene lighting is a simple process using Unreal's Light Mask rendering system. If you want to learn more about using Unreal's Light Mask for creating stunning global illumination lighting in your scenes, be sure to check out the wiki as well as the learning videos on light masks. Up next, we'll cover working with clean geometry
to ensure the best performance and visual fidelity in your real-time scene. Optimized geometry can make the difference between a visually stunning and highly performant real-time walkthrough and one that is lackluster. Geometry with overlapping faces, flipped normals, T-vertices, and overly high poly counts, among other issues, can cause materials to render poorly and can cause frame rate loss on lower-end hardware, or in virtual reality, which requires 90 frames per second to avoid simulation sickness. That means each frame must render at 11 milliseconds or less to maintain a good virtual experience. Let's take a look at some common geometry optimization tricks and debugging tools that will help you avoid these issues. First up, let's talk briefly about quads versus triangles. Now, you can use quads or triangles with Unreal, and you probably won't see any issues. The only real reason to use quads over triangles is that, by doing so, if you need to subdivide a mesh or reduce its complexity for an LOD, it's going to do so in a much cleaner fashion generally. It's a lot easier to subdivide or reduce the quality of a mesh that's made up of quads. Because if you're going to increase the complexity of the mesh, it's very easy to subdivide it into a version that is just as clean as the original version of the mesh. As well as LODs, when you're reducing the complexity, quad-based meshes will reduce a lot cleaner than meshes that are composed purely of triangle soup. So for instance, we see this couch here, which is all triangle soup, and you've got some quads in here, you've got some triangles. It's very messy. So if you wanted to subdivide this, it's not going to do a very good job. If you want to ensure that your mesh is going to render well in real time without any kind of shading issues, it's best to stick to quad-based meshes versus triangle soup like this. Now, obviously you want to avoid things like overlapping faces, which can cause Z-fighting, and you want to avoid T-junctions. Basically, anything that looks bad in your 3D tool, whether it's Max or Maya or Blender, that's going to look bad in Unreal too. So be sure to clean that stuff up using your basic mesh cleaning tools. I know with 3ds Max, you have the Mesh Inspector, which will automatically look for these kinds of errors. You can also enable the XView settings in your viewport to check for things like face orientation, overlapping faces. We can see here we don't have any in this scene. This scene is a very clean scene, well put together for the most part. We can also look for things like T-vertices, overlapping vertices, isolated vertices. Anything, again, that is going to look bad in your 3D tool is going to probably look bad in Unreal too. So be sure to clean that stuff up. Likewise, you'll want to check for flipped normals in 3ds Max here. That's as simple as entering subobject mode and then checking show normals, so I can make sure all my normals are pointing in the direction that I want them to point. Obviously, if there are any normals pointing into the geometry instead of out of it, you need to use a tool such as the flip normals tool, flip those normals. Otherwise, it's going to look incorrect in Unreal just as it would in the 3D tool. Now remember, in real-time environments, you need to maintain 30, 60, or even 90 frames per second if you're doing virtual reality. And that is going to come at a cost to the complexity of your objects, and that includes material complexity as well as the complexity of the geometry. Now, Unreal and modern video cards do a fantastic job of rendering out a large amount of polygons. But of course, if you have a whole lot of objects in your scene, hundreds, thousands of objects, and they're all thousands of polygons each, or it's a very large scene with a lot of objects, you do have to consider your poly counts. So in the case of something like this carpet here, you really should be only using the amount of polygons that you need. This is something that's not always taken into consideration when you're doing renders, but for a real-time object, this flat object here is probably a little over the top in the poly count. So we'd want to use mesh reduction tools to bring this down considerably. Now there are some things we can do in Unreal to find out whether or not we're going to be able to maintain a good level of performance. Let's take a look there. So first off, in the Unreal viewport, we can actually enable some stats so we can see how well it's running. So we'll just hit the little down arrow here on the top left corner and choose Show FPS. This is the very basic amount of information we can get here. So we can see I'm running at about 100 frames per second, maintaining roughly 9 to 11 milliseconds. And that is perfect because that's basically VR level of performance that we need here. If we ran this in a VR headset, we'd be looking great. Everything would be nice and smooth. We wouldn't get any simulation sickness or motion sickness. So that's perfect. We can also get a little more detailed information if we go under Stat, and then we can look under Advanced here or under Engine.
We can also find out about the entire scene. We can see all the details on each object and what the entire scene is composed of. If we click on Window and then Statistics, now this brings up basically a spreadsheet of all the static mesh objects in our level here. We can see we've got 94 meshes, and then we can see how much memory they're taking up. We can also see the number of triangles for each mesh. So we can see here we've got some really high count ones here. This couch, these are obviously the two couches. They're 91,000 triangles. We might want to reduce those. Also, we can open the static mesh editor and get some more details on the object. So we can see here our couch, and then where it says triangles on the top left here, again, 91,472, 57,000 vertices. And that gives us an idea of the count. We can also turn on wireframe to get an actual visual representation of the polygons on our couch here. So the point is that you want to make sure that you maintain that high frame rate for a real-time walkthrough, especially if you're doing VR. You've got to maintain 90 frames per second. It's basically a rule set in stone for any good virtual reality simulation. Unreal Studio does a great job rendering your geometry even if it hasn't been optimized. In fact, this scene you're looking at here, there was very little optimization done to it. It was a clean scene to begin with, but it is kind of high on the poly count. Some of these objects are a little excessive for what they are. That being said, it's still a good practice to optimize your scene and follow good modeling techniques. This is going to save you time and frustration tracking down and fixing issues later that could be causing performance issues or graphical glitches. Just remember, you've got a lot of debugging tools at your disposal in Unreal to help you make sure that your geometry is clean and your poly counts are reasonable. All right, so up next, we'll continue with our discussion on performance and geometry optimization by looking at LODs. Level of detail, or LODs, can be very effective at maintaining good performance in a real-time walkthrough, especially when your scene is composed of hundreds or thousands of objects, each built with hundreds or thousands of faces. Real-time walkthroughs need to run at 30 to 60 frames every second to maintain a good level of visual fidelity, and even as high as 90 frames per second when displayed on a VR headset. And LODs can help ensure that. LODs, for those who haven't worked with them before, are simply lower resolution versions of your geometry. Each version will be displayed by Unreal Studio depending upon how far away it is from the viewer, and thus how small it appears on the screen. Let's walk through the process of generating and importing LODs into Unreal Studio using 3ds Max here. So we have this couch, and we're going to go ahead and isolate it. And we need to generate our LODs. We're going to generate 4 LODs. Let's go ahead and take a quick look at that wireframe. All right, so we need to make copies of our couch. We don't want them to be instances. Okay, so we have our 4 copies, and then we're going to make our second copy at 50%, but first we'll need to add the multi-res modifier to it. All right, so through generating, we're going to set the vertex percentage to 50. All right, so there's our first LOD. The great thing about multi-res is that it does not destroy UVs, so we still have our nice texturing there. All right, and I'm going to go ahead and just create the LODs for the rest of these, and then we'll jump back in after that. All right, so all my LODs are generated. We'll go ahead and turn on edged faces there so you can see the difference there. This is the one at 15%. We've got 25, 50, and then, of course, the original. All right, so now what we need to do is we need to center these on each other. So we'll just use the Align tool for that. Okay, now that they're aligned, we need to go ahead and group them. So we're just going to select them all now and then group. And we'll call this Couch LODs. Now let's jump over to the Utility panel, and we need to add the Level of Detail modifier. We'll create a new set, and there we go. We've got all of our LODs. There we go, 2, 3, 4, and 5, and the percentage for each LOD. So now we're ready to export this. So let's go ahead and go to our FBX export. And in this case, we want to make sure to check animation so that the LODs will be exported. Okay, and in Unreal, we'll just hit the import button and go ahead and bring the couch in. All right, so in the FBX import options, we want to have this static mesh LOD group selected. We're going to choose large prop.
Now, you don't technically have to select this here. You can do it later on, but we'll go ahead and do that now. Also, we want to check Import Mesh LODs. Finally, if we scroll down a little further, we have under our LOD settings, Auto Compute LOD Distance. We'll go ahead and leave that checked by default, and we'll look at the setting when we go into the mesh editor. Let's hit Import. All right, so our couch is finished importing. We've got it here. We'll go ahead and open it up in the mesh editor. If we look over to the right, there's a details panel, and in here we're going to find all of the LOD settings that we need to work with. First up, we have LOD Picker, and this is going to allow us to manually take a look at the LODs. Right now it's set to auto, which means that as I'm zooming out from the couch here, it's actually changing LODs, which you really can't tell because it did a great job of reducing it. But we can turn on wireframe here and see the changes occur a lot easier. So we can see here we're at the maximum, the original couch, and as we move out, we can see it's reducing in quality. Now we can also choose the LODs we want to display, so we'll set it to 0 there, now to 1, and we'll go all the way to 3. Under this, we can see the actual current LOD, what information it has in it. So we've got materials. We can actually change the materials per LOD. So if we wanted to go with a lower quality, smaller resolution material there, and that will help with performance as well. All right, and so at LOD 0, we can also open up some of these settings here, build settings, and there's a lot of information here on various things that you can enable or disable. That's beyond the scope of this course, but feel free to look through all of these settings here if you'd like to get really in-depth in working with LODs. And we also have under that the LOD settings drop down here, the rollout. We have the ability to specify the LOD group, like I said, when we were first importing, how we specified that. We can also change that here. We also have the ability to change the LOD that we're currently using, so we can re-import the LODs and get a different version if we needed to make some changes. We can do that here. Now, if we want to turn off Auto Compute LOD Distance here, so maybe we don't like the distance that the LODs are changing at, we can disable it here. And once we disable that, we just need to scroll back up to Screen Size right there under the LOD 0 dropdown. And right now it's set to 1, so we could change that to 0.5, which would be 50% or less. So we can see now it jumps from LOD 0 to LOD 1 when it's about 50% of the screen. Obviously, we'd want to change all of the other LODs as well to match those settings. Although the scene we're working with is really too small to benefit from LODs, LODs provide a huge benefit to performance in a larger scene with a greater view distance. Using them could very well make the difference between a walkthrough that runs poorly and one that doesn't. All right, so up next, we'll get into setting up collision detection and discuss why you may or may not need it. Collision detection isn't as scary as it might sound. Unreal Studio makes it super easy to add collision to your scenes. But before we get into how to do that, we first need to ask ourselves whether we need it and why. And it really all comes down to the type of walkthrough you'll be creating. Is it going to be a controlled walkthrough in which the viewer simply watches a sequence of animated cameras? If so, you probably don't need collision detection, since the viewer won't be able to move. If, however, you want the viewer to be able to move freely around the scene, you'll need collision in order to keep them within the bounds of your creation. Collision will also help avoid the viewer being able to look through geometry into places you don't want them to see. Here's a quick example of our walkthrough. We'll go ahead and run this. And as I move around, you're going to be able to see that I can move through all of these objects and see into places where I shouldn't. I can also leave the scene through the wall. So this is obviously undesirable, and we're going to add collision detection to fix it. There are two basic ways to add collision to your scene. You can create it yourself in the 3D tool, in this case 3ds Max, or you can let Unreal create it. Let's look at both. Now I've got a collision box here, box 001. First thing you need to take note is that it's completely convex. There's nothing concave to it. Unreal expects if you're bringing in a single mesh object like this for collision that it needs to be convex. You can use multiple different meshes to turn it into basically a concave shape, but in this case we're going to go really simple and just use a single object and make sure it's convex. However, we do need to name it so that it matches the name of our couch. So we've got this couch here, SM Couch 002. So we're going to name our collision box here the same way. So SM Couch 002. The other thing we need to do is add a prefix to it. Now there are several different prefixes you can use.
And each of them basically represents a different type of collision. But 9 times out of 10, when you're doing architectural stuff, all you really need to do is add UCX as your prefix. All right, and now we can go ahead and export both the couch and our collision box using FBX Export. You could also use Datasmith. Okay, all we really need to do here is re-import the couch because it's already here. All right, and then we'll open the couch up in the static mesh editor. All right, and then when we click on collision here, we'll choose simple collision and we can see our collision box. We can also enable complex collision, and this is collision that uses every face of the object. This is very expensive and generally not recommended. So we'll go ahead and turn that off. Now the other option for adding collision would be to use Unreal. So let's go ahead and remove this collision. And then we can add new collision without having to do any of that stuff in 3ds Max, just by going to the collision menu here. And we have several options. So we could add sphere collision. Go ahead and remove that. And then likewise, we've got capsule collision, box collision. Box is pretty good for this object. You basically want to pick the collision that fits your shape. We also have some more detailed collision. So we can go to these 10 DOP, X, Y, and Z, 18 DOP, and 26 DOP, and just try some of these out and see we get a little more detailed collision box there. Let's add the 26. So see that 26 there is even more detailed. Let's go ahead and remove all of these. All right, so we're going to go really simple here, and we're just going to add basic box collision. Now, in the case of the wall here, this wall completely encloses the scene, and it's a concave shape because of that. So let's go ahead and open the wall up and have a look at what we can do with a concave shape. Obviously, we could just come in here and add a basic box for the shape, but that makes the entire area basically collidable. You can't be inside of it. So that's not what we want. So we'll remove that. Instead, we can go under collision and choose auto convex collision. Now this will have Unreal automatically create convex collision for us based on this shape. We've got hole count, max hole verts, and hole precision. I'm just going to leave this as the default value, but using these values here, you can increase them or decrease them to increase or decrease the accuracy of the collision box. Let's see what we get when we do default. All right, so that's what we got from the default settings. It looks good enough to me. I know it's going to keep me inside of the level when I'm looking at it and walking around. So let's go ahead and just save that. So our walls have collision. I know my floor already has collision, and we've added some collision to the couch here. Let's go ahead and give it a test, and we can see how it's working out. If I walk over to the wall here, I can't go any further. So now I can't get outside of the level. And then also, if I walk over to the couch, you can see here, I'm going down a little bit there, but I can't get through it. So there we go. So that's all there is to adding collision. So adding collision can really help make your scenes feel substantial to the viewer. And it provides a realistic feedback as they move around the scene. You'll have to work with an Unreal template such as the first person template, which is what I'm using here, or the VR template if you're doing virtual reality, in order for it to work. But Epic has done a great job making it super easy to set up. So next we'll dive into material support. Getting the materials you've created into Unreal is fairly straightforward, but knowing which materials you can export is necessary to avoid duplication of work. Unreal Engine has its own physically based material system, which can be used to create incredibly realistic shaders. When working with material types in your 3D tool, such as standard surface materials, Blend, Phong, Lambert, or anisotropic, you won't have too much trouble exporting those into Unreal. And Unreal fully supports geometry that uses multiple materials. Bear in mind that some materials and maps, however, such as noise maps, will not export. Also, using two-sided materials is generally not a good workflow practice unless a piece of geometry absolutely requires it, such as this tablecloth here. Unreal does backface culling on all objects by default, so to match, it's a good idea to enable backface culling on your geometry in 3ds Max or whatever tool you're using. You can set materials in Unreal Engine 4 to two-sided as well, but it's often better to give the object some thickness instead, especially if the object uses a translucent material type. One thing to take note of when exporting with FBX is that bump maps will not look correct in Unreal,
So what you want to do before you export with FBX is convert all of your black and white bump maps into normal maps with a program like Crazy Bump or using some other technique. That way, when Unreal recreates the material on FBX import, the normal map will look correct on your mesh. Of course, with Datasmith, the export process will automatically convert all bump maps into normal maps for you. When using Datasmith, you'll also be able to send V-Ray materials to Unreal, a very commonly used material type in architectural rendering. Datasmith will automatically convert the V-Ray material into an Unreal physically based material, with the objective being to automatically recreate the V-Ray material as accurately as possible and saving you time normally needed to recreate it yourself. When exporting using Datasmith, just keep an eye on the output dialog. It'll let you know if there were any material export problems. For instance, this curtain uses a V-Ray two-sided material, which, as of this course, is not currently supported on export. In this case, Datasmith falls back to the first child material of the V-Ray two-sided material on export. That's really all there is to preparing your materials for export into Unreal. There's a lot more depth to the Unreal Material System, and if you're interested in learning how to use it to create beautiful real-time shaders, be sure to check out the Unreal Material Editor tutorials and docs in the wiki. Continuing with our discussion of materials, in the next lesson, we'll go over the types of textures Unreal supports. Unreal supports a great deal of texture formats, including BMP, PNG, TGA, JPEG, compressed DDS textures, and even HDR image maps. The most common formats used are BMP, TGA, and PNG. With TGA files, you get alpha channel support when using 32-bit or RGBA TGA files. PNG files have pre-multiplied alpha support, but are generally not used for most situations. Stick with TGA for the best alpha results. When exporting an asset, the textures used by the asset's materials will automatically be imported into Unreal, assuming that both the material type is supported and the textures are supported formats. Now, Datasmith does a great job of automatically converting textures to a supported format as well. Of course, you can also import textures by themselves. When creating textures for Unreal, keep in mind the max resolution is 8K or 8192 by 8192. Keep your texture sizes a power of 2. Otherwise, Unreal won't generate MIP maps, which are smaller versions of the texture that get used as the camera moves further away from an object. For instance, if we half the max resolution, we get 4096 by 4096 or 4K, a power of 2 texture. But textures don't have to be square. They can be rectangular textures, and those will work just fine. If you are working with a lot of large textures, such as 8K and 4K textures, it might be good to compress your textures using DDS format. We'll look into that in the next segment. It's also a good idea to avoid using alpha channels too often, as they can greatly add to the amount of memory a texture takes up. Just make sure you're not using a texture that has an alpha channel unless the material of the object actually does use the alpha channel. Lastly, let's look at gamma and HDR image maps used for lighting. Generally, you should use a linear workflow, and all textures should be sRGB format with a gamma of 2.2. However, HDR images should have a gamma of 1.0. Generally, the best way to use an HDR image for lighting in Unreal is to import the texture on its own and apply it as a cube map to a skylight. Once you've imported your textures into Unreal, generally done for you when you export your 3D assets, there's still a little setup to do on them to ensure they are being displayed correctly and with as little impact on performance as possible. These options aren't presented on import, but are instead found in the Texture Editor window. Let's open that now. On the right, you'll get some basic info about the texture, such as resolution, whether it has an alpha, and what format it is. Below, we have some options that need to be set. A lot of these options will already be set up for us when the texture is imported, but it's still a good idea to check and make sure they're set correctly. Compression settings allows us to choose from a drop-down the type of compression we want to use for this texture. So this texture is a diffuse texture, so we'd want to use the diffuse texture compression settings. If it was a normal map, obviously we'd choose the normal map compression. Texture group allows us to assign this texture to a group. And by grouping textures together, it basically allows for more control over texture memory. So this is a performance-saving option here. These two options should be chosen by default for you, but if you want to come in here and make changes to them, you certainly can. And then finally, we have sRGB. Obviously, if we're using
sRGB textures, we want to make sure this is checked. Again, this will be checked by default for you automatically. If you need to come in here, though, and uncheck it for some reason, you could do that here. Obviously, a normal map should not have sRGB checked, nor should an HDR image. Now that we've finished preparing and importing all of our assets and ensuring textures have all been properly set up, we're ready to begin working on turning the scene into a real-time walkthrough. Congratulations! But before you do, let's go over a few common issues you might encounter with your scene in Unreal and how you can go about fixing them. Z-fighting is a fairly common problem in 3D rendering and live walkthroughs. It gets its name from the Z buffer of a video card, where the 3D scene's depth information is stored as a texture. Z in this case represents the axis pointing into the screen. Z-fighting can happen for a few different reasons. First of all, simply having overlapping faces that share the exact same space can cause Z-fighting. As we can see here in 3ds Max, we've got a bookshelf up against the wall here. Now the bookshelf has its own back face there that you can see, and that is sharing the space with the wall's polygons and causing some Z-fighting. Another reason is a lack of precision in the Z buffer. Certain situations can increase the chances of Z-fighting occurring too, including very large objects and translucent materials and a few other possibilities. The telltale sign of Z-fighting is what you just saw here, which is basically flickering geometry. If you see this, you've probably got a Z-fighting infestation. What's happening is one set of the faces is trying to be rendered in front of another, and they fight back and forth for dominance. This can be very jarring to your viewers, reminding them that they're looking at computer-generated imagery. Fortunately, most modern video cards boast up to 32 bits of depth buffer, and this can greatly help mitigate the appearance of Z-fighting. In fact, if you're running a very powerful modern card, you may not see any Z-fighting, even if things are overlapping in this way. But if your viewer is running the scene on a lower-end PC, they might not have as powerful of a video card, and the Z-fighting may be more of a problem. So it's important for you to test out your scene on lower-end graphics cards if possible to find out if you've got any Z-fighting issues. Now fear not, fixing Z-fighting is generally very easy to do. Let's look at some of those problems and how they can be fixed. So first of all, with our Z-fighting here in Max, the easy solution here is, well, you can do one of two things. First of all, we could pull this away from the wall so it doesn't have any polygons that overlap with the wall. Even the smallest space would solve the problem here. But if you can't move your object, if it needs to be where it is, the other option, of course, would be to delete some of these faces. Now, I know I can delete these faces here on the wall because they're completely occluded by other parts of the wall. There's trim, there's crown molding up here, the fireplace blocks this area. You won't see any of these faces here, so they're pretty redundant anyway. By deleting these faces, I can avoid any Z-fighting there. Again, the other option would be to move it away from the wall. Now, this may be the only option you have. You may not be able to delete faces. You may just need to separate your objects a little bit, especially if those objects are going to be really far away. Generally, Z-fighting, when you're in a scene that's really small and everything is up close, you're not going to see it as much. But in a larger scene, say an exterior scene, you're going to possibly run into Z-fighting issues, especially if things are very far away. And this is where the lack of precision comes in. And we'll look at a way to fix that. Now, another option would be to use LODs. And again, this is mostly for scenes that are very large and exterior scenes. If you've been following along and you watched the LOD video, you'll know how to create LODs for Unreal. And then generally what you'd want to do is any objects that are causing Z-fighting issues at a greater distance, well, you'd want to have a lower LOD for that object that removes whatever parts are offending, whichever parts are causing the Z-fighting. Chances are you're not going to be able to see those parts from very far away anyway. All right, so here in Unreal, we've got an issue here that's kind of a unique circumstance for Z-fighting. And it doesn't exactly count as the flickering Z-fighting, but it does still qualify as a depth problem. And that is using translucent materials. So what we've got here is I've got 3 translucent materials on top of each other. I've got a translucent wall, which isn't normal, but for demonstration purposes, I've made the wall translucent. I also have a translucent curtain and then a translucent lampshade here. And we can see clearly that there's a depth issue here. And that's because of the way translucency is being sorted on the video card. So in this case, the best solution we've got is to remove some of the translucency, and that will help fight some of these depth problems. But we can also go into the settings and change how translucency works. So if we go ahead and open up the settings, go to our project settings, And we'll do a quick search here for translucency. All right, and we can see under translucent sort policy, it's currently set to sort by projected Z. So if we change this to, say, distance, we get a different look here. So this is a little better, but still not perfect. We've still got some bouncing Z's here, some bouncing Z fighting. We'll try sort along axis, and that's not any better. So you can see here that especially with translucent or transparent materials, Z fighting can become quite a bit of a problem. So let's open up our wall material here, and we'll change this back to an opaque material. And that should help us out quite a bit, actually. All right, so just by changing the wall material, that's helped out quite a bit because now we only have two translucent objects that are competing. Now another option we can try here is the lampshade material. We'll open that up. Right now it's set to two-sided, so let's make it not two-sided. And that helps quite a bit. Now that's because the lamp is composed of a solid mesh that has two sides. It's not just a billboard, so that billboard with the translucent material was what was causing the depth issues. Now there are a few settings that we can tweak in order to try to get a better result, and the first one is the near clip plane. Now the near clip plane is basically, if you know much about cameras in 3D, you know that they have what's called a view frustum. And that has a far plane and a near plane where things are clipped out. They aren't rendered. And the near clip plane is obviously in the front part of the camera, the very closest part to the camera lens. You can adjust that near clip plane, and by making it a longer distance further away from the camera lens, it can actually improve the Z-fighting issues in scenes that are really large, exterior scenes and whatnot. Now the only problem is you don't have access to the far clip plane in Unreal, which means that adjusting the near clip plane may not have much of an effect because generally you want to adjust these two together. They work in tandem. But I'll show you where you can actually tweak it. If we go under settings and then project settings, we can do a search for near clip plane. And mine is set at 10, which I think is the default value. We could obviously make this higher. Generally you want to have a result of between 10 and 30, but if you wanted to make it up to 100, you could certainly do that. Just bear in mind, by tweaking this, you're also going to be making it so that things that are very close to you will be clipped out, and that may create an undesirable effect. So it really depends on the scene you're working on. If it's an interior scene like this, you generally want to keep your near clip plane very low, and if it's an exterior scene where they can't get close to things, you can increase that near clip plane. Now, the thing is, if you change the setting in here, you're going to have to shut down Unreal and restart it. But you can change it inside of the console or the output log. So if we go into the output log, and we type in r.set near clip plane there. So for instance, I'm going to go ahead and set it to 100. And we can see here how it's clipping out very close to me. And that looks, obviously that's undesirable. We don't want that. But if we were really far away, we wouldn't notice it. And that could help improve our Z-fighting problems. Now, we can also do this in a blueprint. So when we run our level, the blueprint can play these events for us. So let's go ahead and do that now. We'll go into our blueprint for the level. And from event begin play, we'll just drag off here and we'll do a search for execute console command. All right, and in the execute console command, we can obviously type r.set near clip plane, and we'll set it to 100. Now, another thing we can do to help improve the accuracy of our Z buffer is to add another command, another console command that basically sets the depth buffer's format. So the options we have for setting the format are 0, which is basically off or poor quality, and then 1, which is the default value, and that is kind of a low quality. And then finally we can set it to 5, which is a high precision value. So let's do that now. We'll go ahead and drag off of our first console command, do another search again for execute console command, and this time the command we want to use is r.gbuffer_format, and we'll set it to 5. Now keep in mind, you are increasing the depth buffer's accuracy here, and that can help combat Z-fighting, but it does come at a performance cost, so use this console command with caution. Z-fighting is a problem you'll most likely encounter when creating large exterior scenes, especially with things with like tall buildings that are very large, take up a lot of space on the camera, or when you're using a lot of translucent materials. But even small scenes with overlapping geometry can sometimes have issues. But knowing how to spot Z-fighting and knowing the techniques to fixing it will have your scenes rendering error-free. Up next, we'll look at how to solve some common light map errors.
Light maps can have several issues once baked, and 9 times out of 10, it's a UV mapping problem. While the automatic light map generation on import works great for most objects, sometimes you have to do it manually. The most common light map problems include overbleed from one UV shell to another, seen as a black or white strip on the edges of a UV shell. Overlapping UVs, seen as black or white spots on geometry where the opposite should be true. And bad seams, seen as kind of a jigsaw puzzle effect or harsh line where there shouldn't be one. All of these issues are solvable with better light map UVs. Let's look at an example of each. So upon baking my light maps, I noticed that in the message log here, Object 199 has overlapping UVs. So if we just click on that 199 there, it's a link, that takes us into the content browser, and I can see here which mesh has the problem. This is the ceiling mesh, and if I turn on my UV channel here, I can clearly see that these polygons, or rather these UV coordinates, are overlapping with these UV coordinates. So this has to be fixed. And so inside the scene, I can actually see this on my ceiling. We've got a black line here where that other UV coordinate is overlapping. And the other thing I noticed is there's a lot of darkness around the edges here and some darkness there. This shouldn't be here. So there's obviously some either overlapping or some light bleed. So we need to fix that. Now this is an automatically generated light map. So we're going to have to go back into 3ds Max and create our own light maps for the ceiling here to get a cleaner light map. So here in 3ds Max, we just need to bring up our unwrap modifier for the ceiling, open it up, and we'll of course need to set our channel to channel 2, and then we'll just pack all our UVs. And we're going to set our padding this time to 0.04. Give it a nice margin of error there. Okay, so now our light mapping UVs look a lot better, nothing overlapping, everything looks nice and clean, nice bit of padding around everything, and we just need to export this back out into Unreal. We have another example here of a common light mapping error, and this is a rounded organic shape. This is a flower vase here, and you can clearly see that it has seaming issues. So if we were to open this up in the static mesh editor and then show our light map UV channel, clearly this is not acceptable. And this is a result of automatic mapping. Now, automatic mapping does a great job most of the time, but when it comes to really organic shapes like this and cylindrical objects, it doesn't know where to put the seams necessarily because it's obviously not a human. It can't use intuition to determine that. And this is where the human factor comes in. So we're going to have to take this into 3ds Max or whatever tool we're using, and then create our own custom light map UVs. And the idea here obviously would be to have one single seam down one side, and all the rest would be cylindrically mapped. So of course we just add some cylindrical mapping here. So we'll add a UV map. We'll set it to cylindrical. We'll go ahead and give it a cap. And we want to set this to map channel 2. All right, and that's going to give us a lot better of a look for our light map. We've got a good cap on the bottom. We've got a good seam along the back of the mesh. This is going to give us already a way better light map than what the automatic mapping did for this. So we'll go ahead and export this back into Unreal. We'll open it up in the static mesh editor, and we're going to go to channel 1 because that corresponds to channel 2 from 3ds Max. And there's our light map UVs. We want to make sure that this channel 1, is specified. So we'll go down to our light map coordinate index and set that to 1. And so there's our vase with the new light mapping. Looks great. Light maps can also be too low res, and simply increasing the light map resolution on each mesh will solve that. You can enable light map density in the viewport. Click on the Lit button here and go down to Optimization View Modes. Click Light Map Density. This will give you an idea of whether or not your light maps are dense enough for each object. Anything red is considered too dense, anything green is basically considered good, and blue here needs more density. Now, while this is a great visualization to give you an idea of the amount of texels your light maps will take up on each object, you're still going to want to judge it by the final look. And that human intuition will come into play here. Obviously, you need to move around your level and just make sure all the light maps look clean and they don't have any blocky appearance and whatnot. Baked GI light maps make your real-time walkthroughs look fantastic, but spending a little extra time creating custom light map UVs rather than relying on auto-generated UVs in every case will add the extra high polish to your lighting. This concludes the course. Up next, I'll offer my final thoughts and summarize the topics we've covered. Thanks for spending time with me and going through the course on data preparation. We discussed how good naming conventions and unit setup help keep your project in both the 3D tool and Unreal Engine organized. We also learned how to use the export and import options for both FBX and Datasmith to bring your data into Unreal. Then we looked at how to properly set up pivot points, UVs, LODs, and collision in preparation for Unreal. And finally, we went over texture and material support before looking at some solutions to common issues. Data preparation isn't a difficult topic to understand, but there are quite a few things to remember. Feel free to rewatch any video to get a refresher later on. The more you practice good data preparation in your projects, the less time you'll waste and the less frustration you'll experience. On top of all that, your 3D walkthroughs will look stunning and run efficiently in Unreal. On behalf of Epic Games and myself, I want to thank TurboSquid for providing the assets you saw in this course. Be sure to check out the Epic Games wiki, docs, forums, and YouTube channel for more info, and we'll see you in the next course. This is Matthew Doyle for Epic Games and the Unreal Engine, wishing you the best with all your Unreal projects. Thanks for participating in the course.